we decided to go to research colony collapse disorder, or CCD. CCD has been affecting colonies since late 2006.
Affects bee colonies.
Yeah, bee colonies. Once the bees, a colony is infected, the bees will abandon the colony, and so
it's not quite clear what happens to the bees. They don't find their bodies; they just disappear from the colony.
The main culprit of CCD is pesticides they use on the crops that the bees are pollinating, and we wanted to see what how CCD affects the price of a certain crop, and we decided to pick almond industry since it's 100% dependent on bees for pollination. And our behavior over time graph shows the population of the bee colonies, and as it decreases, the price of almonds drastically increases.
But there's a maximum point, a carrying capacity, as there's a limit to a reasonable price that anyone would pay for almonds.
Yeah. All right. Now our model.
Okay. So now I'm going to talk about the model and how it all makes sense. Okay. So the first thing that we considered were the bee colonies, the population of bee colonies. And to consider that, we looked at the rate at which they were created and the rate at which they died. And we know that because of CCD, the rate at which they die is going to increase and be greater than the creation rate, so the number of bee colonies will decrease. Then, to see the effects of colony collapse disorder on the almond industry, we had to create a model of the almond industry by itself. So we looked at the inventory of almonds, which is affected by the supply for almonds and the demand. And the supply and demand are both dependent on the price of almonds. And the price of almonds goes to affect the actual price. And then the actual price has an effect on the demand and an effect on the supply. And the effect is dependent on the ratio of the current price to the normal price, the standard price that would not cause any effect on the demand. And the effect the price has on demand is also dependent on a normal demand, as we can assume that in equilibrium there would be a certain demand. And this normal demand, or the demand actually, is dependent on the desired inventory. It affects the desired inventory, as the farmers would want a higher inventory of almonds if the demand were greater. And there's a certain coverage, a certain amount of extra inventory that they want. And the inventory is going to affect the suggested price. And since if the inventory is really high, the farmers want to sell, so that'll make the suggested price go down. And so that goes to affect the suggested price, which creates a gap between the normal change in price and the suggested price, and that affects the price of almonds. And since there's a limit that people will pay, we put in a carrying capacity so that the price of almonds would never get too great. Now, the next thing we had to include was to look at the number of almond trees, because the inventory depends on the trees and how many almonds they produce. So we put in a stock here, 2 stocks actually, where we look at the mature trees, which depend on the young trees and how quickly they age. And the mature trees depend on some sort of rate at which they die. we had to consider the young trees differently from the mature trees, as it takes around 7 years for the trees to actually bear almonds. So they can't produce fruit. And we're only interested in the trees that are producing fruit. Now, we assumed that we had an idea that the trees that are planted, the rate at which they're planted, would be affected by the production of almonds. Because if the trees weren't as productive, since the number of bee colonies had decreased and the bees weren't able to pollinate, then we thought farmers would try and plant more trees to try and meet the demand. So we connected this through some sort of effect that the harvest has on the trees planted, and that effect is dependent on the ratio of the actual harvest to the acceptable harvest. And the harvest depends on the total acres, which is dependent on the trees. And the harvest is, again, dependent on the trees produced, and the almonds produced per acre. And then to link this back to the number of bee colonies, we had to connect it to a normal number of almonds that are produced per acre, and then when the bee colonies decrease, that would cause fewer almonds to be produced per acre. But then we thought that the number of trees might have an effect also on the number of bee colonies, as the pesticide use depends on the number of trees that they have. So to link that, we had to look at the total acres and the amount of pesticides used per acre, which would be some sort of total pesticide use. And then this would have an effect on the death rate. And if the pesticide use were greater than the normal level, it would increase the death rate. And if it were less, it would also decrease the death rate. So this is the final model.
Okay, now for our feedback loop. It starts out with bee colonies, and as bee colonies increases, it'll increase the effect of bees on almonds produced per tree per year, since more bees can pollinate more trees. When this rises, the almonds produced are obviously going to increase also. After the almonds produced increase, that increases the almond harvest, which more almonds are gathered each year. And since there are more almonds in the almond harvest, the farmers don't have to plant as many trees, so the number of trees actually goes down. And when the number of trees goes down, the number of new trees planted also goes down, and that decreases new trees on the farm, which decreases the number of young trees. And the less number of young trees, there are going to be less trees aging on the farm. And since they're not planting any new trees, the mature trees are going to die off, which decreases the mature trees, and which causes the total number of trees on the farm to go down, which decreases the total acres of the farm. Since there's less trees to use pesticides on, the total pesticide use goes down, and since there are less pesticides used, the effect of pesticides on the death rate of bees goes down. So the actual death rate of the bees goes down, and the number of bees dying therefore goes down, which increases the number of bee colonies.
The next thing was we looked at a series of tests a series of measures that would help the almond industry to deal with the effects of CCD, or possibly even to prevent colony collapse disorder. So the first thing we looked at was an increase in the bee colony creation rate. Now, this could be accomplished by the farmers bringing more bees onto the farm, having more beehives. Farmers have now been actually trucking bees around the nation. So this is a slight increase in the number of bee colony creation rate after CCD has been in effect for a certain number of years. And it makes the bee colonies increase, the number of bee colonies, and it also makes the almond inventory increase and the price of almonds decrease. While the price of almonds is still higher and the inventory is still lower than the original values, it does help offset the problem, and in general it helps the almond industry. The next thing we looked at was how different pesticide uses affect the bee colony death rate. And we looked at a series of different rates of pesticide use per acre. And this is after the effects of CCD. As you can see, almost all the pesticide uses that we consider make the population colonies decrease further. But if farmers try and use fewer pesticides, it might alleviate the problem and preserve a higher population of bee colonies. This is our final graph of how colony collapse disorder affects the almond industry. As you can see, the number of bee colonies decrease, which the supply of the almonds also decreases, and the pesticide use increases as farmers are trying to
compensate for the loss of bees, or the loss of number of almonds in supply.
By planting more trees as the number of mature trees increases.
Okay, and some of the final things we learned from this model. Just a slight decrease in bees will spike the price of almonds significantly, as you can see from the graph. And CCD is spreading through colonies throughout America and through the world. And nobody really, although we modeled pesticides being the cause, no one really knows what's causing it, and they're doing studies to find out how to stop it. And like Ian said, it takes an almond tree 7 years to mature to produce almonds. So this gap at which the farmers have to wait for the newly planted trees to produce also affects the farms greatly. And so, in conclusion, we modeled the effects of CCD successfully on the almond industry, and found that it greatly affects it negatively, and we put tests into effect and showed that it can be stopped if the cause is through pesticides. And
yeah, that's it.